Hello everyone. In this session we discuss about natural deduction system. Before learning what is a natural deduction system, let us have a small recap on logic. You already come across first two topics, preposition logic and predicate logic. So let us see how this logic is useful for our AI systems. Logic plays a major crucial role and fundamental role in artificial intelligence systems. Why logic plays a crucial role means artificial intelligence systems has some primary tasks. One of the important tasks is it has to perform knowledge representation and reasoning. To perform a reasoning, we require logic. Similarly, artificial intelligence systems, they do planning and problem solving tasks. So whenever we do a planning and problem solving, so how we solve that problem through a step-by-step procedure involves some kind of a reasoning. That is why we require logic in that environment also. Another task artificial intelligence is a automated theorem proving. Means a AI system has to prove the theorem like a human beings by taking some premises, and it has to infer the conclusions or derive the conclusions from the given evidences where evidences are present in the knowledge base. So there are many problems that require application of a logic. So basically logic is a study of principles of whether a reasoning it basically distinguishes the correct reasoning versus incorrect reasoning. So how this logic is represented in AI, we have 5 methods that help us in deriving valid arguments or valid conclusions from given premises. What is the purpose of these 5 methods is that generally suppose AI systems generate conclusions from the given evidences. When we are generating a conclusions, there is a problem. We face 3 kinds of problems. First problem with the consistency, like consistency means we are proving a theorem automatically, and that theorem may go in a wrong way. Means it is like a theorem wrong way, like one theorem is contradicting with other theorem in that domain. That is one problem of consistency. Means when you are generating a theorems or proving a theorems in a particular domain knowledge base, current theorem should not contradict with the existing theorem. So that is one problem, means we have to maintain consistency. Second problem, when we are making a conclusions, second problem we go the soundness of our theorem proving. Soundness means we have a valid true premises, but my conclusion is a wrong conclusion. Means where premises are true, but my conclusion is a wrong conclusion. So one should not infer a wrong things, wrong conclusions or wrong inferences from the true evidences. So that is the problem of with the soundness. Means soundness means a true premises generally gives only true conclusions. Means your conclusions totally depend on true premises. Means if I generate a false, means that is another problem. Third problem, completeness. Means in my domain, my AI system is generating conclusions from premises. It has to generate all possible conclusions in that domain. So achieving all possible conclusions is a difficult task. So that is why we require a formal framework, a logical formal framework in AA that help us and guide us how to derive the proofs, or how to do a automatic theorem proof using several methods. So we have 5 methods that evaluates our logical arguments by performing a proofs. So they guide us in a correct conclusions from the premises. One is truth tables, second one natural deduction system, axiomatic system, semantic tableau, and fifth one resolution refutation. In the first one, basic method, we till now we used it from our childhood, or in last 2 topics of third unit. A truth table, we all know truth tables, how to write a truth tables. We have different formulas, we prepare well-formed formulas A and B, and we connect those formulas using connective symbols or logical operators, and we take all possible truth values of these variables, and we take the help of these connective truth tables to derive any proof. Let us see how we have done this one. Suppose there is one a statement, a logical statement, that if humidity is today, it is saying that one premises that today is humidity, and another premise is saying that if today is humidity, then it will rain. So another one is it will rain today. There are 3 true premises. Now, is it a valid or one? So if it is humid today, and if it is humid today, then it will rain. So it will rain today. Now, is it a valid argument? Is it a valid sentence? Is it a correct conclusion? A agent today, suppose A agent wants to check whether it's a correct one or not. Shall I go for a conclusion that today it will rain today from the given premises that humidity today, and humidity implies rain. So to do this process, generally if I employ a truth table, what I do, first I make a formula A, it is humidity, B, it will rain, and I take 2 formulas, well-formed formulas, atomic formulas, we say them as atomic formulas. These atomic formulas, from these atomic formulas, to check this entire sentence, I convert it into expression as A implies B and A implies B. That here I am checking whether B is followed. B means it will rain, whether B follows from this premise or not. To check the validity of this one, general truth table, what we do, we make all possible truth values of A and B, then I find the A implies B, then I find A implies B and A, and finally I give the final expression truth value. So each row here is an interpretation of my argument. So if all interpretations are true, then I can say this is a valid argument, because all interpretations are true. If one of the interpretation is true and remaining are false, I can say it is a satisfied argument, means satisfied. This is not a valid, but it is satisfiable. If all the are false, we can say it's a unsatisfiable. In this way, I can check the validity of a arguments in truth tables. But truth tables has one problem, is that as the size of the expression grows, suppose I have here we have only 2 variables or 2 atomic formulas, I can have 2 power 2 4 rows. Suppose my expression contains 4 formulas, my table size grows like 2 power 4, 16 rows will be there. So as when you are making a complicated arguments, when you are trying to prove a complex proofs, this truth table is not useful, means it is difficult, it is not suggested to use a truth table. Then if the truth table, without using a truth table, how we can show that a argument is valid from the given premises? So that is done by our natural deduction system. That is second method we go, means truth table has, it is a very good when expression is simple and your expression is also small one, and show it's a valid, satisfiable or unsatisfied, it is easy. But as expression and premises are growing, it may become difficult. That is a valid proof of a truth table. You can also take help of these logics where one expression can be replaced with another expression, so that you can infer the new rules or new conclusions by just you replace this one with this one, distributive law, De Morgan's law, and absorption. This is a basic class of logic we apply, and we can derive. Means so just we can say the already available tautological formulas, we can use them. So that is about truth table, but still truth table is somewhat complexity issues. So then we go for second one, natural deduction systems. Natural deduction systems is like our human way of reasoning about the things. How we apply reasoning when we want to get the conclusion from the premises, that is mirrored here as one mathematical model. And in next sessions we will learn about how these natural deduction systems are more useful than truth tables. Thank you.